Hello guys, good morning. I'm Zhen from Alibaba Cloud, and I'm also the maintainer of OpenKruise project. Welcome to my speech, and this talk is about the various interesting use cases about in-place pod resizing. It is actually the first debut of OpenKruise in KubeCon North America. So just simple questions. Have you guys ever have heard or just used OpenKruise projects? Please just raise your hand. Okay, a few. Well, maybe that's it, because the result of lack of maintenance for North America. Maybe that's a good starting point. Just a little quick spec recap from those who are not yet familiar with in-place pod resizing. It is a controversial and powerful feature that enables non-disruptive pod vertical autoscaling. And it opens up many possibilities. Now it has graduated to beta, and it is enabled in recent Kubernetes. The Kubernetes community first discussed in-place resizing in the context of in-place update. So we go one step further to enable in-place image update in OpenKruise project. Before the native resizing API in Alibaba, we take a quite programmatic method and implement in-house API for in-place resource resizing. It is the use case of the emergency scaling in the grid promotion. The grid promotion, which is quite similar to Black Friday, but in China, and it has a much larger traffic. In the grid promotion, the traffic surge to very high level, and even through careful load testing, there's still a chance that a weak service can be the bottleneck, and we have to scale the service quickly. In-place pod resizing helps us to scale the service up immediately as much as possible before our horizontal pod scaling can finish scale the pods. Here, my speech will contain just 3 parts. First, I will guide you through the very use case and the tools for in-place pod resizing, which is the major part. And I will continue with some guidelines about the Java application, which will help you to help the Java application adapt to the changing resource requirements. And last, I will conclude with some future works. First of all, one common use case, and actually the most widely used cases from my experience, is the application startup. The application startup problem is quite common and especially serious for Java-based application. When the Java application starts, JVM need to load a bunch of Java classes and compile them into a machine code, which is quite resource consuming. And actually, we can see from the picture that most of the CPU is consumed by non-application code. Then Java community has tried very hard to solve the problem. They have tried to compile the bytecode ahead of time. However, comparing to the compiler just in time, it often comes with a cost of a degraded peak throughput and latency. While using in-place resizing, one can increase the application CPU in the webhook, and when the startup finishes, one can scale the CPU down in a controller. One can also watch for the possible restart event of the container and scale the restarting container up again. The usage is quite easy, and the user only needs to specify the boost factor and the boost duration, which is the wait duration after the pod ready. And luckily, these 2 parameters have simple defaults. For example, we can have set boot factor to 2, and the boot duration just like 5 minutes after the pod get ready. In practice, they work quite well in our users. The application startup cases are just quite easy to use, and actually, because most of the time we only have to scale the resource down after the application gets started. So we actually avoid the problem of reschedule when the resources in a local node is not enough. So we have avoid the problem and we get benefit. Well, we further improved the speed of content restarting by combining in-place resizing with Java technology called CRAC, which is short for coordinate checkpoint coordinate restore at the checkpoint. In such cases, we create JVM checkpoint after startup and restarting failed container but recover them from saved checkpoint. It actually eliminates the need for class loading and just-in-time compiling, which enable almost instant restarting. One may wonder, why not just save the checkpoint in image and start them directly from the image? Well, we find that restarting for the checkpoint has its own troubles, such as incompatible machine architecture and network identity mismatch. So when we start from the restore from the checkpoint from the its own checkpoint, we can just avoid all these problems. Another useful use case is for the stateful application scaling. The stateful application, which may contain not usually the database, but also contain some maybe applications that contain a lot of cache, maybe persist some long connection, such as the game or video applications. When this application get scaled in, one can often face some interrupted task or get broken connection, which will result in computing resource wasted and for degraded user experience. When we try to scale out such application, one can also face some problems such as long pre-warm, which may cause the long request processing during starting periods. Well, in a particular use case of database, one of our database operator in Alibaba, we had used in-place pod resizing to speed up the database during a leader switch. Well, when the operator detects a leader switch is correct, maybe the leader has some hardware problem, it will scale up the secondary instance so that the secondary instance, when it becomes the leader, it will get much more resources to handle the extra request. Well, such scaling will give the DB operator extra time to scale out extra new database instance and get the cache, get warmed. Another common use case is for automatic application sizing. Well, this problem arises in the fact that in most medium or large company, there's actually a gap between the app developer team and the infra team. Well, the app developer team, they are responsible to submit the actual resource request. But as a developer, they deliberately try to oversize their applications and to often significantly overestimate their resource requirement. On the other hand, the infra team, which is usually responsible for the cost reduction, and the only way for the infra team is to apply the vertical pod autoscaling setting for the application developer team. However, current vertical pod autoscaling will just rebuild the pod, which is quite disruptive for the service. So actually, for infra team, they often just refuse to auto-generate vertical pod autoscaling, especially in the production environment for the application developer. So here, we can resolve two in-place pod resizing. And the good news is that in most cases, because the developer has overestimated their resource requirements, in most of the time, we can the only resizing operation is just scale the resource down. Here we have another vertical pod autoscaling we call advanced vertical autoscaling. Now let us revise how VPA just works. First, it will track the long-term resource change, which is often reflect the daily pattern of the apps. And when change is required, it applies change to all pods of the workload consistently. And for individual pod, it applies the change by rebuilding pods with new resources. Well, existing VPA works quite well for workloads with balanced traffic distribution and for repeated jobs such as cron job. However, it is just a bad choice for one-time job and workload with unbalanced traffic distribution. We often call such use cases as the applications that have some hotspot. So we built advanced vertical pod autoscaling, AVPA in short. We track only the short-term resource changes in the period of 10 minutes, which enable AVPA respond quickly to the sudden change of the workload. And the interesting part is that when the change is required, it applied to the change of individual pod, independent of other pods. So for workloads, we may have different resource requirements using AVPA. So that will solve the problem of the hotspot. And for individual pod, AVPA will just apply the change using in-place pod resizing without disrupting the services. AVPA is just perfect for job, unbalanced, and service stable workload. Now let us take a closer look at how AVPA works. Because current AVPA is not open source yet, so I just draft the detail of the implementation. So maybe you guys who are interested can have their own implementations. Just like VPA, AVPA gets its resource matrix from matrix server, and we will push them into a small observer window or periods like 10 minutes or 20 minutes. And it will use the resource statistic in the observer window to drive the scaling target calculation. Unlike VPA, AVPA exposes the HPA like API, which expose detailed scaling behavior controls such as low and high watermark. The AVPA operator will try to keep actual resource usage of each pod in between high and low watermark of AVPA. And similar to VPA, one can select scaling targets using target ref, which support not only the deployment, but also stateful and the job. And in addition to target reference, AVPA also supports generic pod selector, which can be used to match arbitrary workloads or match maybe, for example, all pods in a namespace. The pod selector can be very helpful if we want to apply AVPA to customized training jobs, which often they just use their own workloads or doesn't use any workload at all. So when we apply the change, the AVPA operator will just use the resized sub-resources to the individual pod. In addition to AVPA, we find in-place pod resizing can be very helpful to improve the user experience of the workload level resizing. Previously, the user cannot adjust the resource requirements of deployment or stateful set, even manually, because manually without rebuilding pods, because just the workload controller of deployment of stateful set would just try to rebuild the pod, even only resource requirement is changed. So it's just a pity that our native workload controller cannot integrate pod in-place resizing in their controllers. So as a community for advanced workloads, in OpenKruise, the advanced workloads provided by OpenKruise, such as clone set or advanced stable set, we have integrated in-place pod resizing capability directly in the workload controller. So the user can just change the resource requirement in the pod template of the workload and trigger the in-place resizing of all related pods. Well, the advantage of integrate such capability inside the controller is that when we do the resizing, we actually can work together with just normal rolling update strategy, such as the well-known max availability and the OpenKruise enhanced lifecycle hook. For example, especially for the change involving container restarting, such as memory resizing, because when we resize in memory, for some application, you actually cannot get effect until you just restart the applications. And by applying the in-place resizing inside the workload controller, we can ensure that the traffic is drained before applying the disruptive resizing operations. And for in-place resizing that may involve container restarting, additional protection is actually required to ensure the workload level availability. The pod unavailable budget, the advanced version of PodDisruptionBudget in Kubernetes, support protection of resize operations along with other operations such as eviction, in-place pod updates, or just container restart. Well, this feature is will be shipped in the upcoming OpenKruise 1.9. One common resizing pitfall is how to deal with infeasible resizing, because when the available node memory is not enough for memory resizing, the common practice is to wait a minute and for the rescheduling, the possible rescheduling, or just proactively preempt other co-located pods. However, such practice is just quite slow because there may be not enough low priority pods that can get preempted. And maybe in some multi-tenant cases, you just cannot evict the pods of other tenant. So we have tried another solution called, we utilize the hot migration capability in the serverless container. So when the local node has not enough resources for the resizing, we will trigger hot migration and migrate to another node with enough resources. However, hot migration also comes with its own limitations, and end-to-end migration times may last for 1 minute, because especially for those applications with large memory and very active memory writes. And during hot migration, and at the end of the hot migration, there were also a freeze of container freeze. It will just last for like seconds to sync the memory from local pod to the remote instance. For cases where resizing delay is just critical and we plan to use another approach, well, this is to scale the resource up as much as possible if the full resizing is not possible. Well, this operation is not yet well supported in the native Kubernetes, because currently Kubernetes will not report available resources of the node in the resize operations. Now let's go to the second part, because in e-commerce application, there were using a lot of Java applications. So we have provided some tuning guide for the JVM to better utilize the in-place pod resizing. So when we apply the instant pod resizing to Java application, JVM parameter must be tuned to match the vCPU after resizing. Otherwise, the JVM may not able to update the CPU effectively. 3 parameters matters most. Two of them will control the GC threads in the parallel GC and the concurrent GC phases, and one of them control the just-in-time compiler counts. And here is a table, and one can just reference these numbers. When we scale the memory up, there's also some JVM parameters to tune. During memory scaling up, there are just the parameters are the initial heap size and the maximum heap size. We have to ensure that the maximum heap size is larger than the initial heap size, and the container memory limit is greater than the maximum heap size. Well, it is actually quite contrary to some common practice. Well, the developer will just set the initial heap size to the maximum heap size. Well, which in such cases, the in-place pod resizing is not possible. Well, worth noticing that although heap growth is supported by OpenJDK, auto memory risks still exist if the speed of memory resizing cannot match the one of memory usage increasing. So in Dragonwell, the improved JDK from Alibaba, also open sourced, we can make sure that the JVM grow the heap size only within the scope of current available memory. Well, this feature will be released in the next Dragonwell version. During memory scaling down, the parameters to tune are the min and the max heap free ratios. The default setting of them from OpenJDK are often too large for in-place pod resizing, so maybe you can try to tune them down. It was noticing that the OpenJDK release really unused heap memory back to OS only during the concurrent mark phases and the full GC phases. It will only recycle the memory of older generations. So in other words, the current implementation of OpenJDK is not effective enough when recycling memory and may slow down the full GC phases, because in full GC phases, we will just stop the world. Also in Dragonwell, we have improved this behavior. It will recycle the memory of both young and older generations, and will significantly improve the speed of memory recycling. Here are some future works we plan. First is we try to implement some cron VPA, which will just scale the resource up and down using some cron tables. Also, we try to integrate this advanced vertical autoscaling with Kubernetes event-driven autoscaler. The third is we'll try to integrate with HPA, utilize the best effort scaling, which is the case we start with in the promotions. Well, here are some tips. Well, you can get involved and learn more and find our project in GitHub. In addition, there is a maintainer track this afternoon and about the progress configuration delivery by another maintainers. You can also reach us in the OpenKruise channel of a Kubernetes Slack workspace. Okay, here's my content. Do you have any questions?
Oh, that works. Okay. So is the ultimate idea to update just a general idea to update the pod controller so that so the resources field is mutable, and then that'll be the integration point between like VPAs and HPAs once it becomes like more adopted among CNCF? Like outside of kind of OpenKruise and OpenKruise's like closed source implementation of it? Do you know?
Yeah, actually, the community are driving to the graduation of the in-place pod resizing capabilities. Yeah, actually, there is some progress. For example, some works in the HPA community, or to try to also in the VPA community, they will try to just incorporate in-place resizing capability. But from my experience, that it will involve a lot of code-based change. Yeah, so we just choose another implement the pod working control from scratch, and also there are some works in the CUDA community. They will also try to incorporate the pod in-place resizing. Yeah, because why we are fast in implement this is because in OpenKruise we have a key feature is that we have a in-place pod update capability. So it's very natural to incorporate the pod resizing capability. Yeah, but we can foresee that there will be more integration in the upstream Kubernetes community. Yeah, because this feature is quite useful. Yeah.
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 And if I can ask a follow-up question, if I have an existing deployment of a stateful application that can only have one replica for whatever reason, how would I transition that application in its normal pod spec to using something like that OpenKruise can offer?
Actually, if you try to use something like the AVPA, it doesn't matter what the workload it is. But if you want to integrate the pod resizing capability with the workload controller, currently you have to migrate your workload to the OpenKruise clone set or something other workloads such as advanced tool set. Yeah.
Okay, cool. Thank you so much.
Yeah, we do provide some tools to help the migration. Yeah.
Okay, and I can get it at that repo, right?
Yeah.
Perfect. Thank you, sir.
Hi, 2 questions. First one, does it have to be CPU memory for scaling? Can it be a metric, a different metric, like latency, throughput, or is it only memory and CPU today?
Actually, we currently just use the matrix, maybe some percentile matrix of the CPU and memory. We don't use other matrix. Yeah.
Yeah, okay, because HPA itself can use other metrics, right?
Because currently AVPA require on the utilization of the resources. So currently we haven't figured out a way to incorporate some maybe business matrix. Yeah.
Okay. And the checkpoint, how long does the checkpoint take of the JVM after you've done startup?
Do you mean the correct technology?
Yeah, so you were talking about doing like a checkpoint here, yeah.
Yeah, actually, the crack is just a very common technique. Well, it may not be present in the OpenJDK, but many advanced JDKs, maybe for example, the JDK from Bellsoft, they all provide such capabilities. Yeah, not just the Dragonwell. Other JDK can also have such capabilities. Well, the reason why cracks is not wide adopted is because one have to change their JDK, which is not possible for many companies.
All right. Okay, thank you.
Hey, I have one question about if you actually want to reduce the size of the container, like say from 4 cores to 1 core, or like say the memory reduced from 10 gigabytes to 8. And in this case, the heap size should also be reduced at the beginning, right? So how are you guys actually decide the initial size for the heap if you reduce the memory size?
Yeah, actually for Java application, one have to plan ahead that how many resource it can change. So it will just change design ahead that the minimum resources, how much is the minimum resource, and how much is the maximum heap size. So because you cannot change this parameter on the fly, so when you create your container, these parameters have to be set statistically. But the actual value is not necessarily the same as the initial container resources. So you can just set maybe larger container resources and use the AVPA to just scale the resources as in demand to the actual values.
Gotcha. And another question not related to the vertical resizing, but it's like, how are you guys actually try to integrate the HBA with VPA or vertical resizing with horizontal resizing? How are you guys actually do that?
Yeah, actually, it's just a quite sophisticated problem because the horizontal pod autoscaling also rely on this matrix to guide their autoscaling. Yeah, the key idea is just to complement the HPA to make the application to scale the application up as much as possible during emergency. Yeah, but we have to deal with the possible conflict behavior of 2 separate work controllers.
I see. Thanks.
Yeah.
Hi, I had a couple questions. The first one I was curious about was Do you have any issues with like conflicts with the main scheduler? Like say the Kubernetes scheduler is trying to put a new pending pod onto the free space that you're growing into for the existing pod?
Of conflicts of what?
Like in terms of like concurrent behavior where you're enlarging, like scaling up an existing pod on a node, and then at the same time, the main Kubernetes scheduler is trying to place a new pod onto that same node at the same time onto those resources?
Oh, well, actually, the Kubernetes will just will be the last decide whether or not to admit such resize operations.
Okay, so it's actually involved, like the main Kubernetes scheduler is involved in the decision to grow the pod?
Well, actually, the scheduler is not involved, but Kubernetes will just decide, he will arbiter whether or not to accept such resize operations.
Okay.
If that's not possible, he will just reject the resize operations.
Okay, so it's just relying on the Kube API like synchronization to check that the resources are still available when accepting the grow.
Yeah, when such operation is not possible, there is a pod status indicated that such resizing is infeasible.
Right.
Yeah.
Okay. The second question I had was for the user application. So you were talking about like the JVM realizing that there's more or fewer CPUs or more or less memory. Does the application code itself, like if it needed to resize a worker pool or connection pool, does it also like is it also able to just check the JVM like how much free memory is available? How do you deal with that, I guess, in practice in your applications?
Yeah, a very good question. Yeah, actually, the problem does exist. So the applications have to set up maybe a proper value for the maybe the number of thread pool, maybe to some medium value in the middle of the max and the minimum CPUs. Yeah.
Okay. Yeah, that's all I have.
Okay. Thank you.
Hi. Maybe a bit of a follow-up to the previous question, but could you talk a bit about how the VPA works together with like resource limits and requests? And when sizing like pod limits and pod requests on memory and CPU, should we be taking like the upper bound of the VPA into account, or how does that work?
Work with what?
Sorry, the pod limits and requests on like memory and CPU resource requests and limits?
Actually, mostly we just address the request of the pod. Yeah.
Oh, so the VPA it basically is a controller for the resource request. No.
Yeah, you will adjust the resource request of the pod.
Got it. Okay. Thank you.
Hello. So I think in our environment, I think it's kind of like useful in the sense that we have a cluster. It probably have different SKU. I mean different node types. Some are having more modern CPUs. Some are having more like legacy CPUs. So performance could be very different.
Yeah.
So I think the advanced VPA, like you can do the resizing on a per pop basis. It is particularly useful for our use case.
Yeah.
This is one comment on from mine. And the other thing is I'm wondering, like, for example, if you have a workload that is already running and, for example, you downsize the CPU's count or something, is it gonna, for example, something or, for example, for some Golang process, they're depending on the number of CPU like during the startup. So is this gonna have a negative impact, or how do you guys like handle that like in your practice?
Oh well, yes. Actually, the Golang has improved a lot in the sense of to sense the actual available CPU resources. Yeah, but again, that they can aware the initial CPU size, but if we resize them on the fly, yeah, it's hard to know whether or not they can just adjust to the new CPU values. Yeah.
Okay. Okay. Thank you.
Thank you for the presentation. I'm from LinkedIn, where our our computer platform heavily relied on your clone set project.
thank you.
Yes. I have a question regarding the in-place scale down, actually. Because in our Kubernetes cluster, in some of the pools, we have a heterogeneous SKU. So we have our scheduler profile to attach the pod to the SKU that perfectly work optimal for the workload. So in case a pod is in-place scale down, then make some lower SKU, right, feasible or schedulable for this pod. Does this in-place scale down support a feature that, in that case, prefer reallocate the node, reland the pod to a lower SKU instead of keeping the pod on the higher SKU?
Do you mean just reschedule the pod to another node?
Yes. In some of the scenarios, yes.
Oh, well, yeah, currently we have employed, in one cases, we will try to migrate the node pod to another node. That is when the pod, when we change the resource requirement, we end up change the pod QoS because the Kubernetes doesn't accept the change of a pod QoS. So in such case, we will try to just migrate pod or evict and rebuild pod in another node. But in your cases, I think it's quite interesting, and we can maybe discuss it later. Okay.
Cool. Awesome. Thank you.